Which of the following correctly shows trapezoidal approximation of the area under the curve represented by f of x is equal to x cubed minus x plus 1 on the closed interval 1 through 7 using 3 subintervals? We're going to solve this problem in 3 steps. Step number 1 is we're going to find the subinterval. So delta x is equal to 7 minus 1 divided by 3, which gives us an interval width of 2 for each of the 3 subintervals. Step number 2 is we are going to divide the function into 3 trapezoids, and each trapezoid will have an equal width. So this purple curve roughly or crudely represents f of x, and we're going to find each trapezoid. Now remember, the interval starts at 1 and goes to 7. So we're going to start our first trapezoid at 1. It has an interval width of 2, so we start at 3. Our second trapezoid starts at 3 and goes over to 5. So it also has an interval width of 2. And our third and final trapezoid starts at 5 and ends at 7. So there are 3 trapezoids, each with an interval width of 2. And notice the interval goes from 1 through 7. Step 3 is we're going to set up an approximation using the area of the trapezoids. So keep in mind that the general area of a trapezoid is 1/2 times the height times the sum of the bases. The height, in this case, is going to be the interval width. So wherever you see h throughout this problem, h is going to be 2. Because the height of the trapezoid, and remember, the height of the trapezoid is actually the distance between the 2 parallel legs. The 2 parallel legs run from the x-axis up to the curve. So B1 and B2 are going to be represented by f of x at the various intervals. So for example, B1, the distance from the x-axis to the curve is going to be f of 1. And also B2 is going to be the distance from the x-axis to the curve, so that's going to be f of 3. That's our first trapezoid. The second trapezoid is going to go, again, it's 1/2 times the height, so the distance from the x-axis to the curve at x equals 3 is going to be f of 3. And B2 in this case is going to be the distance from the x-axis to the curve, so that's going to be f of 5. Trapezoid number 3, the area is still 1/2 times the height times the sum of the bases. However, in this case, for the third trapezoid, the distance from x equals 5 up to the curve is f of 5. And the last leg, the distance from the x-axis to the curve at x equals 7 is going to be f of 7. So this is how we get our 3 different area formulas. To find the total area, we're going to add up the areas of those 3 trapezoids. So each one has 1/2 x or 1/2 h. That's going to get factored out. And I want to point out something else. Trapezoid number 1 ends at f equals 3. That's the height of that last leg. While trapezoid number 2, the height of its first leg starts at f equals 3. It ends at f of 5. So that's where this one ends, the height of this leg. But trapezoid number 3, the height of its first leg starts at f equals 5. So we have a bit of an overlap. So when we're setting up our sum, you'll notice that there's our 1/2 of 2. 2 is our height, so that we factored that out. We have f of 1 plus, here's my 2 times f of 3 because that occurs twice, once in trapezoid 1 and again in trapezoid 2. And then we have 2 times f of 5 because that also occurs twice. And then we add up 7. So this is the setup that you would use to solve the approximation using the area of the trapezoids. So the correct answer is going to be D.